Welcome. In today's video, we'll be discussing the limits of a function. First off, the definition of a function can be described in this notation where as x approaches a number c and L is a single number. Therefore, if f of x in a function approaches from either side of c, the limit of f of x is arbitrarily closer to a single number L. In this function, we can say that as the limit of x approaches 0 is equal to 3. Now, in this case, we simply plug in 0 as x into the fx plus 3, and we got 3 for an answer. However, in order to determine the limit must exist. And the existence of a limit determines whether you can solve a limit problem or not. Thus, in order for a limit to exist, the limit as f of x exists only if the limit from both sides of c approaches L. It's also given in this notation. Now, in the example graph we have here, the limit as x approaches negative 2 from the left side and the right side is given as 3. In this case, this point right here. Therefore, the limit does exist in this case. Now, there are multiple types of limits, and one of them is the infinity limits. And in this case, we can say that the limit of f of x as x approaches z is infinity or negative infinity. So, in this example graph we have right here, you could say as the limit as x approaches 0 of f of x is equal to infinity. You could clearly see that as it approaches from the left side and the right side, it goes to infinity. But take a note that technically the limit does not exist because infinity isn't a real number, but the answer is either infinity or negative infinity. It's just a way of expressing a limit. And another type of limit is a non-existent limit. So, non-existent limit is when a limit as x approaches c from the right side of f of x is equal to a number, but it's different to the number as x approaches c from the left side of f of x, which is a. So a limit does not exist when a limit as x approaches c has a non-removable discontinuity or jump. In this graph right here, we can see that there is no limit because there's a jump and non-removable discontinuity. There are multiple ways of finding a limit, one of them being direct substitution. In direct substitution, you can simply plug in x as c into f of x and get the limit. In this case, the limit as x approaches 10 and x divided by 2. So you plug in 10 and x divided by 2, you get 10 divided by 2 equals 5, and this would be the answer. However, there are cases when direct substitution fails. In this case, if you use direct substitution, you get an indeterminate form of 0 divided by 0, which cannot be the answer. Therefore, you have to factor, clean up fractions, multiply by the conjugate, swap trig identities, simplify logs, or just plug in numbers with graphs and tables. So, in this case, we could factor out the numerator, which is x squared minus 1. And we know that's x minus 1 times x plus 2. Now, since they both have x minus 1, we could clean up the fraction by removing this. And then we get x plus 1, which is the limit as x approaches 1 and x plus 1. In this case, the most simplified form, we can use direct substitution and get an answer of 2. Therefore, this example is an example where direct substitution cannot work, but you can still get the limit by either doing one of these options or multiple of these options. So here's a practice problem. Limit as x approaches 4 and 2 minus square root of x divided by x minus 4. So if we use direct substitution right now, we get 2 minus square root of 4 divided by x minus 4, which is an indeterminate form of 0 divided by 0. Therefore, to solve this limit problem, we have to use multiple methods. So in the first step, we'll multiply the conjugate in the numerator and denominator, which is shown in this step right here. Now, we could further simplify the numerator by knowing that a plus b times a minus b is a squared minus b squared. So 2 minus square root of x times 2 plus square root of x is 2 squared minus square root of x squared. So we can simplify the top further and get 4 minus x. And we notice that 4 minus x is also found in the denominator. So we could cancel out these two and get this. Now we could use limit as x approaches 4. So limit as x approaches 4. And in this case we can use direct substitution. So that just equal 2 plus 2 equals 1/4, which is the answer to this limit problem. Thank you for watching.